Right, folks, today we're going to learn more about the unit circle that we talked about last class and how we can use it to determine expressions dealing with sine of an angle, cosine of an angle, or tangent of the angle. And last time we learned angles aren't just measured in degrees, sometimes they're measured in radians. Okay, so these first 12 problems we're not going to work with for a little while. We're going to talk about this circle that you see to begin with. So it is called the unit circle, remember, because we have a radius of 1 unit. But you'll notice on this picture we were also given that this circle is on a coordinate system. So what we're going to do is talk about some of the points along this circle. We know there are infinitely many, but there are 4 at nice values that intersect our x and y axis. So I want you to put dots on all those corners for me. And because we know this radius is 1, we can find the ordered pair that corresponds to each of these dots, knowing from the origin that we're going to the right 1, so 1, 0. From the origin going up 1 is 0, 1. Left 1 is negative 1, 0. And down 1 is 0, negative 1. But we're going to talk about standard rotation. So last time we focused on this segment rotating it around, and we know when we're talking about rotations they go counterclockwise. So what we'll do is attach rotations at each of these points to what they correspond with. So if this is my starting point, this would be 0 degrees. And then up here you can see the nice right angle being formed, so that is 90 degrees. And then keep going, we've got 180 degrees, and down here 270. And 0 degrees is the same thing as 360 degrees. You'll notice as you go through here, some of the numbers get larger because we can continue around this circle extra laps if we wanted to. But the next thing we want to do is understand what these things mean in radians as well. Okay, so we're actually going to start a little backwards here, and I want you to start with this 360 that we learned last time was the same thing as 2 pi in radians. And with that, we can kind of cut our circle into sections to figure out the other pieces. If I cut it in half, I know 360 divided by 2 gives me 180. Similarly, 2 pi divided by 2 gives me pi. So 180 degrees is just 1 pi. From 180 to 90, I split it in half again, so instead of pi, this would be 1/2 pi, or pi over 2. Now for right now, I'm going to call it 1/2 pi because that's going to help us find other measurements, but in general, as we go throughout this chapter, you're going to see the paper giving you this version of the 1/2 pi instead. Okay, they're equivalent. We're writing this for now. You will see the pi over 2 most often. Okay, from there, we can find this bottom part knowing that we've got 1/4 of the circle, 2/4 of the circle, 3/4 of the circle, and we just decided that each one of those quarters, or 90 degrees, stands for 1/2 pi. So this is 1/2. This here was 2 halves, which makes sense because 2 halves is 1 pi, and down here would be 3 over 2 pi. And then finishing up with our 2 pi. 0 in degrees is also 0 in radians, so you'll see that sometimes as well. Okay. The last thing we need to know is how in the heck this relates to the questions that are being asked over here. So what I want to talk about for a minute is these ordered pairs. We know a traditional ordered pair on a coordinate system looks like x comma y, so go ahead and write that down. And what I'm going to tell you today is that this ordered pair relates to trig as the x value being the cosine of the angle, and the y is the sine of the angle. Now remember, this angle is talking about rotating this radius around here, and the corresponding point represents the cosine at that given angle, or the sine of that angle for the y. Now, we're going to talk about why that's actually happening next time, but for right now I just want you to take my word for it. So, sine is y and cosine is x. It's in alphabetical order. Okay. Last thing we need to talk about is the tangent. So I don't want you to draw this, but I want you to just pay attention here for me. When you first learned about sine, cosine, and tangent, it was in right triangle trigonometry. You had some angle defined, and from that angle you could designate the sides of this triangle as opposite of the angle, adjacent to the angle, and the hypotenuse of that right triangle. And then your sine was given to you as the opposite over the hypotenuse, cosine was adjacent over the hypotenuse, and tangent was the opposite over the adjacent. And you remember that with SOHCAHTOA. Alright, so for tangent, it's equal to O over A, but what we're going to do today, and this I do want you to write down, is talk about tangent instead of opposite over adjacent, because we're dealing with a circle and not a triangle here, is we're going to call it sine theta over cosine theta. Okay? And then I'm going to show you how it does tie into this stuff that you learned last time. If we do some substitution here, sine over cosine would look like opposite over hypotenuse on the top. That's substituting in for this sine. And then cosine would look like adjacent over hypotenuse. And anytime we have a fraction within a fraction, we want to eliminate it by multiplying by the reciprocal. So this is equivalent to opposite over hypotenuse times h over a, and those h's cancel out, leaving us with OA is tangent, as we know. Okay, so it's not really a proof, but it does show you that this really is the same thing as what you did learn. Again, we're going to talk about why these things are actually happening in regards to that triangle next time. So now that we know that, here's how these problems are going to work. These questions ask for the sine, the cosine, or the tangent at a given angle. Our first step is to find the point that corresponds to that angle relating to the unit circle. So 90 degrees, starting here, we go 90 degrees going backwards, and we're going to write down the ordered pair that goes with that angle, so 0, 1. From there, we're going to decide what this tells us in terms of that ordered pair. And remember, sine goes with y, so we're looking for the y value of that ordered pair, which is just 1. Okay? To kind of convince you that this is actually working the way it's supposed to, we're going to test it. So grab your calculator for me. Again, this is not a proof or an explanation about why it's happening. That'll come next time. Okay, but it will convince you at least that I'm not just making this up. So in your calculator, we want to make sure that because this is dealing with degrees, our mode is in degrees. So check your mode for me. Make sure degree is highlighted. If it isn't, change it for me. And then type in sine of 90 just like we see it. And we get 1. Okay, so it matches up. Looking at the next one, this is why I wanted you to write this top one as 1/2 pi instead of pi over 2, because what we're going to do is count. This says 7/2 pi, so we're going to count 7 of those around our circle. So hover with your pencil over 0 for me, and I don't want you to mark on your circle like I'm doing, but follow along with me here. That would be 1/2 pi, then 2 halves, then 3 halves, 4 halves, gets me back to where I started, 5 halves, 6 halves, and 7 halves, puts me down here at this point. So I'm going to write that point, 0, -1. And then we're finding the sine again, so we're looking for the y value. We're at -1. If we wanted to check this one in our calculator, you'd have to switch back from your degree mode to your radian, but I'll just show you that this one works as well. And sine 7 pi over 2 equals -1. Alright, so just to kind of give you a heads up here, when we're going through problems like this, it is my expectation that we're doing this without a calculator. To ensure that you're actually doing that, you're going to write this ordered pair, which your calculator cannot do for you, and your homework quiz covering this stuff next class will be non-calculator. Okay, so just reminding you of those things. All right, next up we're going to look at cosine of negative 90. We learned last time that negative just means we're going clockwise instead. So this time, starting from my 1, 0, I'm going down 90 degrees, so I'm at 0, negative 1. Same point as last time, but this time I'm looking at the cosine value, which is x. So the x-coordinate of this point is 0. Next one we have radians, so it says pi. Pi on our picture is already labeled there, okay, but it's halfway around the circle, so we're writing down negative 1, 0. And cosine, again, we're using the x value, so negative 1 for that one. Number 5, we get to see tangent for the first time. Okay, so tangent we decided was sine over cosine. We'll have to use both of the coordinates in our ordered pair. So tangent of 270, we got to find where that angle lands us first. So starting from our 1, 0, going around 270 degrees lands us at the bottom. So 0, negative 1. And tangent, remember, is sine over cosine. But looking at here, sine is your y value and cosine is your x, so this would be y over x. And for us, that looks like negative 1 divided by 0. We know we can't divide by 0. That's a problem. If you were throwing it in your calculator, it would give you an error. We're going to call dividing by 0 undefined. Okay, tangent is undefined at 270 degrees. And then cosine here, it's got a negative 540. This is clockwise again. Okay, we're going past 360. This is what I was talking about earlier. Sometimes we keep going on our picture. So here, we're starting and going backwards. There is 360 degrees. And we have to keep going 180 more to get to 540. So this is the ordered pair negative 1, 0. And if you didn't know it was 180, automatically, just subtract off your 360, and that's really where that's coming from. Okay, so we're at the point negative 1, 0. Cosine tells us look at the x value, negative 1. Okay, I want you to pause the video and try out problems 7 through 12 for me, and then I'll let you check them. Alright, we're going to run through these really quickly because you can throw them in your calculator to check them if you needed to. This is negative 3/2 pi, so there's 1, 2, 3/2 going clockwise, would be at 0, 1. Sine is y, it is the number 1. 5 pi would be 1, 2, 3, 4, 5 times around. So I'm at negative 1, 0, and that would look like y over x. So 0 over negative 1. This time the 0 is on top, so it reduces to 0. 2 pi all the way around is 1, 0. Again, we're doing y over x, and it ends up being 0 on top again. This is clockwise, so I'm going clockwise 360 and then 90 more. So that is 0, negative 1. Cosine is the x value. I look at the number 0. 5/2, we've got 1, 2, 3, 4, 5. I'm at the point 0, 1. I want the sine value. The y is 1. Negative 360 is the same thing as regular 360 in terms of the point. And tangent, I've got 0 over 1, which is 0. I want to talk just for a minute about the tangent values here. So tangent ended up being 0 a lot of the times, but it also had the possibility of undefined. If you notice, our points only have the number 0, 1, or negative 1, then you should be able to see that sine and cosine only have the options of 0, 1, or negative 1. The same thing happens with tangent. Because 0 is going to be involved somewhere in the fraction, there's actually only two options, 0 or undefined. Okay, when we look at where 0 is on these ordered pairs, there's a pattern. On these two values, the 90, the 270, or the pi over 2, the 3 pi over 2, where fractions are involved, the 0 comes first, which means these ones are undefined. Okay, so at the top, tangent is undefined, bottom, tangent is undefined. If I go the other direction, 0 it comes in the second part, which means it would be on top of the fraction. So tangent for these ones are both 0. And how you can kind of remember that to save you some work with these tangent problems is thinking about slope. Okay, so if we think about the slope of this vertical line, it's undefined. If we think about slope of horizontal lines going through left and right, the slope is 0. Okay, you can always get there by filling in your fraction and doing the math, but that is a quick way to determine. If you see a half in your answer, for like radians on tangent, it has to be undefined. If you see a whole pi for your tangent, it has to be 0. Okay, next thing we're going to do is talk in general on sine and cosine, not necessarily specific angles, but how to work kind of backwards here. So it says, using the unit circle, decide which quadrant of the coordinate plane makes both expressions true, and then give the values of theta between 0 and 2 pi that describes that quadrant. So what I want you to do first here is this needs to be moved over here. It got scooted over. But we're going to draw a little unit circle on a coordinate system to kind of think through these problems, what it's asking us. The first thing it says is we want the cosine to be less than 0. So cosine, we decided a little bit ago, was x value of the coordinate system, and less than 0 is just a fancy way to say we're only looking at negative numbers. So on a graph, if we're thinking about the coordinate plane, x goes left and right on the coordinate plane, and we want it to be negative, so that means to the left. So everything to the left is negative, and if we think about on the unit circle, that would mean that portion of the circle has negative x values. Similarly, we can look at the second piece. The sign part here means y. Greater than 0 means positive. So we want our y values on this to be positive. So if we go back to our picture for this one, on the coordinate system, y is up and down, and because it's positive, we want to go up. So all of this in the coordinate system is positive, and if we're thinking about the unit circle, it would be this curve right here. We want to determine the piece that satisfies both of these expressions, so it'd be just this part of the curve where we see that cross-hatching. Okay? So that is, if you remember, quadrants are labeled starting over here at the top right and going counterclockwise again, backwards. So that is quadrant 2. So on line 1, let's put Q2. Okay, from there it says we don't want to talk about it as all of quadrant 2. We want to talk about the angles on the unit circle that satisfy these points on the curve. That's where those angles we were talking about a little bit ago at our points matter, because this quadrant starts at this point and ends at that one. But it does tell us we want the angles in radians because it says 0 to 2 pi. So this at the top we know from the starting point is 90 degrees, but we want that in radians, so that is pi over 2, or 1/2 pi. Then it ends over to the side, that's 180 degrees. That for us is pi in radians. We're going to write this, though, in interval notation. I don't want just those values, I want the things between those values. So we're going to put a comma, and we have to decide whether these should be parentheses because they don't actually work at those individual values, or brackets because we want to include that 90 degrees, include that 180. Okay, so we're going to go check this on our picture here. At this point itself is 0, 1. And we're just going to check if both of these are true for that point. So here, cosine is supposed to be negative. Our cosine was 0. 0 is not a negative number, so that point doesn't actually work. We want a parenthesis there. On the next one, we're looking at this point over here. I'll go ahead and label it -1, 0. We want to check that cosine is negative. The x value here is a negative number, so then we can move on to the second requirement. It has to fit both. We didn't have to look at the second one for this point because it didn't work for the first one, so we could all automatically say we wanted a parenthesis. For this part, we want sign to be positive, and because sign is 0, doesn't work again. Okay, in general for these when we're talking about positive or negative numbers, 0 is not going to work, which means these will always have parentheses involved because our points are going to have a 0 involved in them somewhere. Alright, let's try this next one. Draw a picture again. We want sign to be less than 0. See if you can highlight where that would be based on what we did here. Okay, remember this is y is a negative number. Hopefully you came up with the bottom section because y is up and down. Now this second part we need to think a little bit about. It says tangent is less than 0 or tangent is negative. You can go ahead and write that part. And what we're going to do for this one is talk about points in general. So in quadrant 1, we have all points being positive because we go to the right and go up. In quadrant 2, we're going to the left and then up. So the x value would be negative if I'm going to the left, and the y value would be positive. In quadrant 3, we're going left and down, so that would be negative, negative, and right and down for quadrant 4. We want the tangent to be negative. Tangent just divides the sine over cosine or the y over x. So positive divided by positive is positive tangent for the first quadrant. Positive divided by negative is negative. Negative divided by negative is positive. And negative divided by positive is negative. So tangent is negative in this quadrant and this one. And we want where they overlap, so that means quadrant 4 is the winner. And we want to describe it going around counterclockwise, the first angle to the last one. And so this one in radians, remember 1/2 pi, 2/2 pi, 3/2 pi. And we end at 4/2 pi or 2 pi. Parentheses around just like last time. Alright, first part, cosine is greater than 0. That says x is positive. So to the right on this circle for that one. Okay, but it says sine equals 0. We want to know in here where y is equal to 0. Not positive, not negative, exactly 0. And that's happening really on this curve here. But what's really important is I don't care about all of this, I just care about where it hits the circle. So it would be this point and this point, and the overlap only happens at this one. So that point is the winner, and we're writing it as an angle. It's not a quadrant for this one, so this one we're going to put NA on the first part. It's a specific angle, and it's at our starting point, which would mean it's 0 radians, or we could say it's 2 pi radians. Okay, those both satisfy it, and it says from 0 to 2 pi, so I'm just going to include both of them. Okay. The next piece is just kind of like a multiple choice thing. We're selecting whatever works for our answer here, and these aren't just going to be values at one of our 4 original points, but they're going to end up at the points that you see along here. Our job is to figure out where this angle would be, knowing what we know about the unit circle. So what I recommend doing here is putting your angles on for the points you do know. I'm using those as reference to the rest of them. Now, I'm usually not going to do this for degrees because you're pretty familiar with degrees where you could figure that out, but we're just going to go around with the radian values. So this is 1/2 pi or pi over 2. This one is pi. This one is 3/2 pi. And this one is 2 pi. And with that, we want to figure out where negative 2/3 pi is. I want to emphasize this fraction here. We know we're going clockwise, and we're just going to think about the number 2/3. So I know that 1 pi is right here. Okay, I'm going clockwise. There's 1 pi. You just want to think, is that fraction more than 1 or less than 1 to place it on the grid? Okay, because 2/3 is less than 1, we know we're going to have to be down here somewhere. We've got 2 options, here or here, And we just have to figure out which one's more likely to be 2/3 if all of this is 1. Okay, and we know 2/3 is bigger than a half, so it has to be this ij. Okay, just like last time, we're going to write the whole ordered pair and then pick the one that works. Because it's sine, it goes with the j value. Next one works the same way. We're going to look at the fraction. This time it's going counterclockwise like normal. Okay, so 7/12 is less than the number 1, and we have to decide if it's more likely to be this number or this one. 7/12 is past a half, because 6/12 would be a half, so it's got to be the EF. And from there, we want the cosine, which is the x value, so we're ending with E. All right. 540 degrees, I'm going all the way around. That's at 360. I have to go 180 more to get to 540. So this one is at GH, and the cosine is G. 3 pi happens to be in the same place, okay, because 1 pi, 2 pi, 3 pi, so it's also GH. This time, though, it wants the sine value. Alright. On number 21, this should have said 4/3 pi, so fix that. But then I want you to pause the video and do those last 4 for me, please. Alright, this pi over 6 is right here, small fraction, d for sine. Here, 4/3 pi is that ij that we were talking about earlier. The I is the cosine. 7/4 pi is 1 3/4, so 1 3/4 would be over here, the KL. And from there we want the K value. Negative 720 goes 2 laps around backwards. I'm at AB, and I want to choose the B value. The last thing we're going to do is an application of the unit circle. Okay, it's a circle, so things with circular motion can be applied using this stuff here. They give us some information here. It says, as of 2021, the largest Ferris wheel in the world is the Ain Dubai. And this thing is massive. It's 250 meters tall. Okay, so think about that, feet to meters. And then the diameter of this thing is 230 meters. Because our brain doesn't like to work in meters very well, just to give you some idea of how really huge this thing is, there are 48 cabins around the wheel. So each of these spokes ends with a cabin that holds people. Inside of these cabins, it's not a normal Ferris wheel where you sit, 2 to 4 people. 40 people can walk around in these cabins. Okay, to put it into perspective, imagine this cabin as the size of 2 double-decker buses squished together. Okay, so really huge orbs here that are going around the circle. And if we think about this circle, what we need to do is kind of combine our ideas with the unit circle in a way that works for this particular surface. And these are kind of the things that we need to think about to answer questions. So I'm going to ask you questions like, what is the height of any of these seats around? And in order to answer the question, we have to think about, well, if we're talking about an ordered pair XY around the circle, which of those would actually help us determine the height? Okay, so just like we were talking about with the quadrants, we need to think about this as up and down or left and right, and height, of course, is up and down, dealing with the y value. And we learned today that the y value goes with sine of whatever angle gets you to the point you want. Okay, but that's not the only issue. We also have to think about the scale change. The unit circle has a radius of 1. We need to find out the radius for our wheel. Okay, so with the information we're given, we're going to go ahead and draw on our picture here. From top to bottom, we were told that it is 250 meters high. And then it said the diameter was 230. Okay, so from here all the way to the bottom, that's 230. With 20 left over would be this distance. Okay, 20 meters off the ground for the bottom of the wheel. Okay, that's huge. And then from there, we can determine the radius that we need because that's our scale change. So our radius for this is half of our diameter, so it'll be 115 for our scale change. Now it says how far above the ground is the horizontal. What I want you to do is draw the horizontal from the origin of your circle across. That's what they're talking about. They want to know how far off the ground is that. Okay, and if we're thinking, we know our radius is 115, and we've got 20 more, so that'll be 135 meters. Now the reason we need that is because when we're talking about the unit circle, the center of our circle is at 0, and all this stuff here is below it. We don't want this stuff below that horizontal to be negative, so we've got to shift it up into positive land. Okay? So when we talk about these two things in combination, their scale changes and translations, we can write an equation. I know my parent function happening here is sine theta because that was what we talked about up here. A scale change often shows up in the front because we're multiplying, and a translation often shows up at the end as a plus 135. And that will give us the height of any seat as long as we know our theta is starting from that horizontal and going around. So, to answer some questions here, we want to just be able to look at the seats they are giving us and make sure we know where they are in reference to that horizontal. So I'm going to redraw mine on there for it. But some of these, we may not have to use that formula for. Okay, so hopefully you notice that B is way at the top of the circle and D is way at the bottom of the circle. Those ones we don't need the formula for because we can see visually how far off the ground they are with our given information. Okay, we decided this 20 was happening at the bottom based on the total height minus the diameter. So we're going to skip to part D and answer that question. So that one's just 20 meters. We can do the same thing with B. It told us at the beginning the height of the Ferris wheel was 250, so B is going to be 250 meters without any work. It's the other ones that we have to use our formula. Okay, so I know that my formula is going to be 115 sine of some angle. I'm going to leave that angle blank for right now, plus 135. Our job is to go figure out that angle from our horizontal. Okay, so if we think about our circle, we know that straight up top is 90. We know over here is 180, and we know down here is 270. Okay, but we're not sure what each of these little spokes references right now. We can find it though. We know all the way around the circle is 360 degrees. We just have to figure out how many sections that is split into. Okay, I want you to go through the reading and figure out how many sections there would be on this without counting because they told us in the reading. Okay, there was 48 passenger cabins and 40 passengers in each one. Okay, I don't care how many are each one, I care how many there were, so it's divided by 48, which gives us 7.5. So each one of these little sections is worth 7.5 degrees. And now that we know that, we know there's 1, 2, 3, 4 of them. We're going to take 4 times 7.5 to get that angle, and we're going to do that before we put it in here. Just wanted to have you show your work here so you remember what you did to get 30. Then we're going to go to our calculator and type that whole thing in. Okay, so keep in mind here that your mode still has to be in degrees, so I changed mine to show you that it worked. I want to get it back to degrees, so this works out for us. 115 sine 30, close your parenthesis, that's important, plus 135. And we've got 192.5. We're just going to ask ourselves if that seems like a reasonable number based on what we know about our circle. Well, we know that the highest number possible is 250. I know that this lowest number possible is 20, and I know that the middle ends up being at 135. So I just know that mine has to be between 135 and 250, and it is. Okay. Looking at the next one, C is down here. We're not going to count how many sections it has total. We're going to find a reference point. So you're going to find the closest nice value. So out of your 90, 180, 270, and 360, you're going to find the one that's closest. And this one's closest to 270. So we're going to take 270 and subtract however many sections we need. So 1, 2, 3, 4, 5. In your calculator, if you want, you're taking 270 minus 5 sections, 7.5 each. So that gives me 232.5. Make yourself some notes so you don't forget what you did. Theta is 270 minus 5 times 7.5. Okay, and then from there, we're plugging that into our calculator. Okay, so same formula as before. If you want to just go grab the formula from before, you can. And then we're just changing our angle to 232, and I'm going to do an insert here so I don't have to retype something, 0.5. There it is, 43.8 meters. We're just going to round. Let me see if I remember that right. 43.8. Okay. Alright, so that one, let's see if it's reasonable. It has to be between 20 and 135 at the bottom. It is, it works out. Alright, that last one is on you. Pause the video, take care of that, and I will flash you the answer here in a bit. Alright, last one here, angle was 345 because we're taking 360 minus 15. That's 7.5 twice. And then our number with 105.2 seems reasonable because it's lower than that 135. If you have any questions while you're going through your homework, please come see me. And do not forget we have a non-calculator homework quiz next class.